Okay, question 9, we have differentiation from first principles. It is broken down a bit for us there. So in part A, f of x is x squared minus 4x plus 2, and we want to find f of 3 plus h. Giving our answer in the form h squared plus ph plus c, where b and c are integers. So, f of 3 plus h is what we get when we substitute x equals 3 plus h into f of x. So, f of 3 plus h is equal to 3 plus h squared minus 4 lots of 3 plus h, and then add 2 on the end. Okay, so if we expand out the first bracket, we get h squared, add 6h, add 9, and then from the second bracket, we're going to get minus 12, minus 4h, plus 2. So we've got h squared. Now we got 6h minus 4h, so that's going to leave us with 2h. Then we got 9 minus 12, which is minus 3, add 2 is minus 1. So there is f of 3 plus h. Okay, then for part B, we are told our curve passes through the point P with coordinates 3, minus 1, and the point Q where x is 3 plus h. Using differentiation from first principles, work out the gradient of the tangent to the curve at point P. So we are given the formula for differentiation from first principles. It should be on screen. So we know them. F dash of x is the limit as h tends to 0 of f of x plus h minus f of x all over h. So we are trying to find the gradient at the point where x is 3. So what we need is f of 3 plus h, which is lucky because that is what we worked out in part 1, part A. So that's h squared, add 2h minus 1, and we also need f of 3. Now we also know that that is the y coordinate that we get when we substitute x equals 3 into the curve. So we know the coordinates of point P are 3 minus 1. So f of 3 is minus 1. So f of, we want the gradient at the point where x is equal to 3. So that is the limit as h tends to 0 of f of 3 plus h, so h squared add 2h minus 1 minus f of 3, so minus 1 gives us plus 1, and then that is all over h. So this is the limit as h tends to 0 of, well, the 1's cancel out, so we are left with h squared add 2h over h. Now there's a common factor of h, so this is the limit as h tends to 0 of h plus 2. Now, as h tends to 0, h plus 2 tends to 2. So, our answer is 2. Cool.